Hello everyone, welcome to the next lecture on the Laplace transformation. Today I will explain you how you can evaluate the Laplace transformation when small t is written in the denominator. I will explain you this lecture with the help of the 20 examples so that you can learn it simple manner. You can simply follow my YouTube channel where there is a playlist of the mathematics 2 and you can find the various lecture related to the Laplace transformation and its various applications. So as I told you, what is the objective is, we will see how you can solve the Laplace transformation when small t is written in the denominator. It may happen that in some question it's a t square or it will be the t cube. Again you will apply the same rule as here. What is the rule is, whenever you have a Laplace transformation of t, make sure the first of all the limit should be finite. If limit is not finite, then you are unable to find the Laplace transformation. Whenever you have a finite limit, then the Laplace transformation will be s to infinity fs. Second way, if you have the function f of t divided by t square, now it's a degree 2, then you have to double integrate from s to infinity fs ds ds. What is the fs is? Laplace of the remaining quantity. You can see what is the fs is? Laplace of the remaining quantity. Now the proof is very simple. I can give you the proof is a single line. Start from this fs. What is the definition of the fs? It's from 0 to infinity e raised to power minus s into t f of t dt. Now look at the right hand side. I need an integration of this. So I can integrate with respect to s from, I need a limit from s to infinity. So what is the left hand side? S to infinity fs ds. So this number will be s to infinity s to 0 e raised to power minus st ft dt and ds. Now I can change the order of integration. So 0 to infinity inside, that comes to outside, and s to infinity is inside. S of t, this is ds f of t into dt by using change of the order of integration. Fine. And that lecture you have studied in your last semester, that is the order of integration. Now can you do the integration of this? It is e raised to power minus st over minus t from s to infinity f of t dt. When you substitute infinity, it is my with respect to s, so you have to substitute it will be the 0. When you substitute s, is a minus minus plus e raised to power minus st f of t over, so what is that? You can see I can think about this as another function. This is my Laplace of ft divided by t, and that is the required answer of this problem. So I can summarize for you in this type form, like Laplace of this, I can change the order of integration. Integration of this component will be my here, and then you will get the right answer. So let's start with this question. Firstly, how you can find this Laplace transformation of this part? You can see that t is written in the denominator. So since the degree is my 1, so you have to from s to infinity Laplace of the remaining quantity. Fine. But before that you have to check whether the t approaches 0 of this value is finite or not. So clearly say this number is my 0 by 0 form. So I can apply the L'Hopital rule. When you apply the L'Hopital rule, it's a e raised to power minus over 1. So clearly say it is a minus of 2 is finite. So therefore you can find the Laplace transformation of this. What is the Laplace of this? It's a 1 over s. It is 1 over s minus 2. Now can you integrate them? There is no need to take the LCM. So integration is ln of s. It is ln of s minus 2 from s to infinity. I can return this number is ln of s over s minus 2. Fine. When you substitute infinity, it will be infinity by infinity form. Then I can apply the L'Hopital rule. It's a 1 over 1. ln of 1 will be 0. So this part is 0 minus, when you substitute a lower limit, it is my here. or that I can written as minus. I can adjust them by changing the sign, by changing the numerator to the denominator is the right answer of the problem. Look at this another one. Again, your target is to evaluate this one. So I can written this is s to infinity Laplace of 1 minus cos at of ds. So before that you have to check whether the limit t approaches 0 of this quantity exists or not. So 1 minus 1 is a 0 by 0 form. So I can apply the L'Hopital rule. It's a minus minus plus sine of at. So when you substitute 0, then answer is 0, which is a finite number. Then you can integrate them. Laplace of 1 is 1 over s, is will be s over s square plus a square. Now you can integrate them. What is the integration of this? Is the ln of s. What is the integration of this? If I simply take s square plus a square is my y, then s into ds will be dy over 2. So this integration will be dy over 2 over y, that is half ln of y. So half ln of s square plus a square from s to infinity. I can take 2 as LCM. So half ln of s square. Why? Because if you take the LCM 2, then it's a 2 ln x. It will be my ln of s square minus ln of s square plus a square. Now again I can apply the ln of a minus b is ln of a over b from s to infinity. Now let me clear this one. So when you substitute infinity, it's my infinity by infinity form. So that means when you substitute infinity, say infinity by infinity, I can apply the L'Hopital rule. It's a 2s over 2s 1, ln of 1 is 0 minus ln of s square over s square plus a square. So I can adjust the negative sign of half s square plus a square over s square is my right answer of the problem. Look at this another one. Again your target is to find this number. So clearly say when you take the limit t approaches 0, it's a 0 by 0 form. So when you substitute, when you apply the L'Hopital rule, it's a minus a sine of at minus minus plus b sine bt over 1. Answer is 0, which is a finite number. So s to infinity, Laplace of the cos will be s over s square plus a square. Laplace of this will be s over s square plus b square of ds. Now how you can integrate them? I can multiply by 2 and divide it by 2. So it's a half ln of s square plus a square. Again this is half, so I can take an half as a common. Ln of s square plus b square from s to infinity. So half is outside. So this number is ln of s square plus a square, s square plus b square from s to infinity. Now when you substitute infinity, the answer will be 0, and when you substitute the lower limit, it is my s square plus a square, s square plus b square. So again you can see I can adjust the negative sign. So half ln of s square plus b square, s square plus a square is my right answer of the problem. Okay, look at this another one. It is ln of this. So 1t is appears, so infinity from this number. So but before that you need to check what is the limit of t approaches infinity 0 of this number. So it is not a 0 by 0 form, it is 1 over 0, that is infinity, which is not finite. Fine. So once it is not finite, it means the Laplace does not exist. So make sure always this condition must be the finite in order to evaluate this problem. Otherwise, if you want to solve them, again you will see that it will be 1 over s minus a. Fine. So then it will be ln of s minus a from s to infinity. So what is that? Ln of s infinity. Here and you can see this does not exist. Again you can see it does not exist. But before that you have always try to check it firstly whether it should be the finite or not. Okay, look at this one. Again your target is to find this one. So firstly I can find the limit t approaches 0. So it's a 1 minus 1 0 by 0 form. I can apply the L'Hopital rule plus b sine bt over 1. So it's a and it's a 0 which is a finite number. So that means I can find the Laplace of this number, at minus cos of b into t of ds. So what is the Laplace of this? From s to infinity 1 over s minus a, it is s over s square plus b square of ds. So it will be ln of s minus a, it is half ln of s square plus b square from s to infinity. So I can return half is I can take an outside. So half s minus a whole square I can return minus ln of s square plus b square from s to infinity. Again I can simplify this. It is ln of s minus a whole square divided by s square plus b square from s to infinity. If you substitute infinity, it's an infinity by infinity form. Then you have to apply the L'Hopital rule. So twice of s minus a of 2s. So again it's infinity by infinity. It's a 1 over 1. So ln of 1 is 0 minus half ln of s minus a whole square over s square plus b square. Again I can adjust the half. So that will be s square plus b square divided by s minus a whole square is my right answer of this problem. Okay, now again your target is to find this number. Now you can easily verify that limit t approaches 0. It's a 0 by 0 form. So I can apply the L'Hopital rule. So it is my over 1. That's a 0 which is a finite number. So that means you can find the Laplace transformation of this component. So how you can find the Laplace of the sine square t? Firstly, fine. So I can find the Laplace of the sine square t here. So the Laplace of the sine square t I can written as 1 minus cos 2t divided by 2. Half is outside. Laplace of 1 is 1 over s. Laplace of 2t is s square plus 4. So I can substitute this value as here. So the Laplace of this will be half is outside. Then 1 over s minus s over s square plus 4. Now can you integrate them? Half is outside. It is ln of s minus half ln of s square plus 4 from s to infinity. So again I can take 1 by 2 is common. So it is half s square minus s square plus 4 from s to infinity. So that will be 1 over 4 ln of s square over s square plus 4 from s to infinity. When you substitute infinity, again it's a 0, and when you substitute s, it will be s square over s square plus 4. Now I can adjust the negative sign. It is 1 over 4 s square plus 4 over s square is the right answer of this problem. Okay, look at this another one. Again your target is to find the Laplace of this, and you can that you can easily check that whether this limit is finite or not. It's a 0 by 0 form, so definitely it's a 1. Whatever the numerator part, you have to use the product rule. It is a finite number. Now how you can find that? It is s to infinity because it's a single t, so that will be sine of 3 into t cos of 2 into t of ds. How you can find this Laplace? Now since it is a product form, so I have to multiply by 2 divided by 2. So what is the formula for the 2 sine A cos B? It is sine of A plus B plus sine of A minus B. So I can apply this formula here. Half from s to infinity Laplace of sine 5 into t plus sine of A minus B of this quantity. So what is the answer of this? So s to infinity Laplace of this is a 5 over s square plus 25 plus 1 over s square plus 1. Fine. Now what is the answer of this? What is the integration of this first part? 5 will be outside. Laplace, what is the integration of 1 over x square plus a square? It is 1 over a tan inverse x over a. So in this case a will be my 5, 1 over 5 tan inverse s over 5. A will be my 1 tan inverse s over 1 from s to infinity. So that number will be cancelled out. Now 1 over 2 is outside. Now if you substitute infinity, tan inverse infinity is pi by 2 plus tan inverse infinity is pi by 2 minus tan inverse s over 5 minus tan inverse s. So now you can see half pi by 2 plus pi by 2 is pi minus tan inverse s over 5 minus tan inverse s is the right answer of this problem. Look at this another one. Again your target is to find the Laplace of this. Clearly say the limit is a finite number. When you take this is a 0 by 0 form, I can apply the L'Hopital rule. This minus minus plus e raised to power minus bt. So that will be minus a plus b, which is a finite number. S to infinity Laplace of this 1 plus a, Laplace of this is s plus b. Fine. Now what is the integration of this? S ln of this minus ln of this from s to infinity. So that will be ln of s plus a over s plus b from s to infinity. So when you substitute infinity, is a ln 1, that's a 0, ln of s plus a over s plus b. So I can adjust the negative sign. It is ln of s plus b over s plus a is the right answer of this problem. There's a similar same question about here. You can find it by on. Okay, how you can find this? This is the Laplace of this number. So s to infinity, again you can see that the limit is a finite number. You can check about that. This is my finite number. Moreover, in this case it will be the 0. 0 is the finite number. So the Laplace of 6, it will be s square plus 36 and it will be s over s square plus 60. Fine. Now what is the integration of this? Half is common. It will be ln of s square plus 36. Half is again outside. It is ln of s square plus 16 from s to infinity. I can return this number is ln of s square plus 36 divided by s square plus 16. Again you can see if you substitute infinity, it is my 1. So it is half. Ln 1 is 0. And when you substitute the lower limit, it is my s square plus 16 over s square plus 36 plus 16. So what is the right answer of this? Half ln of s square plus 16 divided by s square plus 36 is the right answer. Okay, again this part. Now that you can easily calculate it, limit you can easily calculate it. So I can start directly from here. Laplace of e raised to power minus t sine square t. How you can find the Laplace of this part? So clearly say whenever this term present, that means you are using the shifting first theorem. So let me firstly calculate the Laplace of sine square t. How you can find that? I can return this quantity as this form. So what is the answer of this? Half is outside. It is 1 over s and it will be s over s square plus 4. Then by the shifting first theorem, what is the Laplace of minus t sine square t? It will be half. I can replace s to be the s plus 1. So s plus 1 square plus 4. Fine. So I can substitute this value as here. So that means you have to talk about the integration of this component. So that will be half is outside, s plus 1 and s plus 1 over s plus 1 square plus 4. This is from here. Now what is the integration of this first component? Half. It is my ln of s plus 1. Again half, I can multiply half and divide it by 2. So it will be s plus 1 whole square plus 4. So again I can multiply by 2. So I can take the LCM 4. It is ln of s plus 1 square minus ln of s plus 1 square plus 4 from s to infinity. So that comes to be 1 over 4 ln of s plus 1 square divided by s plus 1 square plus 4 from s to infinity. When you substitute infinity, it's a 0, and when you substitute s, it will be this number. So that is the right answer of this problem. You can adjust the negative sign. So that comes to be ln of s plus 1 square plus 4 divided by s plus 1 square is my right answer. Okay, look at this another one. Again your target is to find this number. That you can easily check that whether this limit is a finite or not. So clearly say it's my finite number. Fine. So Laplace of this value. So how you can find the Laplace of this? So again I can start from the Laplace of the sine t. It is my 1 over s square plus 1. Fine. This is s to infinity. So what is the Laplace of e raised to power t? So it is s plus 1 square plus 1 of ds. Fine. So what is the integration of this? It is my tan inverse s plus 1 over 1 from s to infinity. So when you substitute infinity is a pi by 2 minus tan inverse s plus 1. And what is the pi by 2 minus tan inverse? That's a cot inverse s plus 1 is the right answer of this problem. There is one more method that directly come in mind right now. Now what is that? Instead of finding like this way, I can found Laplace of this number. Fine. So I can firstly found the Laplace of this quantity. Fine. And then I can apply the shifting first theorem. So firstly I can find the Laplace of sine t over t. So that comes to be this Laplace of the sine t, that is 1 over s square plus 1. So that comes to be tan inverse s over 1 over a tan inverse of this. So what is the answer of this? Tan inverse infinity pi by 2 tan inverse of s. So that will be cot inverse s. So therefore using shifting first theorem, so what is the Laplace of e raised to power minus t sine t divided by t? So what you can do, you have to replace s to the s minus a, so s minus 1. So that is cot inverse s plus 1, and you can see both the answers are same. The same way you can do this example also. You can find the Laplace transformation of this value and then use the shifting first theorem. You will get again the same answer. Okay, look at this another one. Again, this is my exponential term. So there are the two methods. Firstly, I will tell you the both methods. Firstly, I can find the Laplace of this value. Fine. And then I can use the shifting first theorem. So that will be s to infinity Laplace of sine hyperbolic t. What is the Laplace of the sine hyperbolic t? It is 1 over s square minus 1. So how you can do that? I can use the partial fraction. So s plus 1 s minus 1. So what is the partial fraction of this? S plus 1 and s minus 1. It is ds. So it is a half, it is minus half. Fine. Now what is the integration of this? I can write for here. Half is outside, ln of s plus 1 minus half ln of s minus 1 from s to infinity. I can write here. Okay, so this number will be this. So half is outside, it is ln of s plus 1 s minus 1 from s to infinity. So when you substitute, infinity is a 1 and minus half s plus 1 s minus 1. So that means half ln of s minus 1 s plus 1. So that is the Laplace of this quantity. So therefore, by using the shifting first theorem, by the shifting first theorem, what is the answer of this? Laplace of e raised to power minus 2t sine hyperbolic t over t. So I have to replace s to be s plus 2. So half ln of s to be the s plus 2, that is a s plus 1 over s plus 3 is the right answer of this problem. This is the first method. Second method is, again, how you can find the Laplace of this sine hyperbolic t over t. So I can apply the definition. It comes to be s to infinity Laplace of minus sine hyperbolic t. So I can find the Laplace of this quantity. Sine of this will be 1 over s square minus 1. So Laplace of this, by using the shifting first theorem, it will be s plus 2 square minus 1. So I can open this. It will be s square plus 4 plus 4s minus 1. That is s square plus 4s plus 3. So I can factorize them. S plus 3, s plus 1. So I can substitute here. It is s to infinity 1 over s plus 3 and s plus 1. Now how you can integrate them? I can use the partial fraction. It is s plus 3 and s plus 1. So I hope all of you know that how you can do the partial fraction. I can substitute s plus 3 as a 0. So s will be minus of 3. I can substitute s is minus 3 in this value. So it is 1 over minus 2. Then for the second case, I can put s plus 1 as a 0. You will get s is minus 1. I can substitute in this value. So it will be 1 over 2. So what is the integration of this? Minus half ln of s plus 3 plus half ln of s plus 1 from s to infinity. So I can written half is outside. It is ln of s plus 1 s plus 3 from s to infinity. So when you substitute infinity, it is my 0 minus ln of s plus 1 s plus 3. I can adjust the negative sign. It is ln of s plus 3 over s plus 1 is the right answer, and you can verify it from this previous one also. So there is a reverse sign. Can you identify where is the error? It's a s plus 1 over s plus 3. I got s plus 3 over s plus 1. Can you identify where is the mistake? I will check this part firstly. Yes, this is the mistake. When I take s plus 1, this number is a negative. Fine. When you substitute s is equal to 1, this number is my positive. Fine. So this number is my negative. So I can take this minus as a common. Minus minus plus. Fine. So there is no need of here. Fine. Then I can replace s to be the here. So it is s plus 3 and s plus 1. That is a partial fraction. That's my mistake. Fine. So you can see from the both side you will get the same answer. So these questions are exercise for you. You can solve it and let me know your answers in the comment box whether you will get the same answer or not. Still, if you have any doubt, you can contact me at any time through my email IDs. I hope you can share this video with your friends so that they will also learn in a simple manner. Thank you very much, students. Happy learning.